Guys, long time I'm not uploading the video, but then as you can see, we are having a question, geometric question, and we are required to find so this is the square is inscribed in a triangle. So as you can see, this is the triangle with the sides length of 3, 4 and 5, and we are required to find the area of the shaded square. So first of all, when you encounter this kind of question, of course you need to determine what method or approach to solve this question. But first of all, we need to label the square, the side length of the square. Let's say it has the length of x, because it is square, so the side lengths are the same for the four sides, right? And this is x, this is x. Okay, and this is 90 degree, of course. And suppose this is angle alpha and this is beta, right? So we can say that alpha plus beta is 90 degree. Okay, and this is also 90, this is also 90, and this is beta, because we said alpha plus beta is 90, so alpha plus beta plus 90 is 180, right? Because it's what we call the postulate for in math, saying that the sum of the angles in the triangle always 180, and this is supposed to be alpha, this is beta, right? This because this is beta plus 90 plus alpha must be 180, and this is must be alpha. So you observe that. So let's label this triangle A, this small triangle, and this small triangle is B, okay, and this is C, right? So we observe that these three triangles are similar because it has same angle inside it, right? Alpha and beta, involving alpha and beta and 90 degrees. So we can say when this occurs, then we can say triangle A similar to triangle B similar to triangle C. So when we are having this statement of similarity, so we can expect the ratio of the side length of the each triangles are the same, right? Their ratios of each length are the same. Okay, let's analyze first. So let's start first with this big triangle. Okay, we extract first triangle A. This is 90 degree, of course, and let's say this is A. This from this point to point, this point is A, and from this point to this point is supposed to be B, small b, not big, not capital B. Okay, and probably we can say that this is D. Okay, so this is 5 minus x minus D, right? So for triangle A, what we have, this is 3 minus A, right? This is 5 minus x minus D, and this is x and triangle B is, I'm drawing this using my free hand. Oh, salah. So this is 90 degree, and of course this is B, this is D, and this is X. This is triangle B. For triangle C, this is A, this is 4 minus B, right? And this is X, right? And this is the big triangle. So let's get started. Okay, we take triangle B. Okay, so we see, since we take triangle B is similar to triangle A, so I take the side length, this X. Sorry, let me label the angle first. That one is X, so this is alpha, this is beta, right? And for triangle A, this is beta, and that one is alpha. So let's start with X over D. The ratio X over D is similar, so we find what angle similar, what side length X similar to this triangle. So you can see this beta and this beta, when you rotate it, it will what we call overlap, right? So this X will overlap with this 5 minus X minus D. So 5 minus X minus D over, so the value of D, which is similar to triangle A, is, of course, you can see it is X, right? It overlaps within the X value, so it's X, right? So this is equation 1. So we have the variable X and D, and we need to find one more equation which has X and D inside it. Actually, you can what we call implement for the triangle A with triangle C. This is triangle C, but it will be more difficult to solve the equation. So let me use this big triangle, and correlates it with maybe with this triangle X, triangle B. So we can say, since big triangle big similar to triangle B, so we just write X over D for triangle B, and we find the similarity of the length in big triangle over here. So as you can see, this is beta, and this one is beta, and this is 90 degree, and this is 90 degree. So this must be similar to X, right? So we write 3, okay, over, and the length D similar to this triangle must be 4, right? When you rotate this you rotate and you overlap this D will be similar to this 4. Okay, so we have two equations with two variables, so it is solvable. Okay, so for X, we just do like we just eliminate the fraction like this, and we get X equals to 3 over 4D, and we substitute 2, 1. Okay, so whatever X inside the equation, we just subs it with this. So 3 over 4 D Sorry, no, we want to find the value of x, so d equivalent to 4 over 3x, so we subs to 1, so x over 4 over 3x, so 4 over 3x equivalent to 5 minus x minus 4 over 3x divided by x. Okay. So we just simplify the fraction. This is 20 over 3x minus 4 over 3 x square minus 4 over 3 square x square, and this term has x square and x square, and we just move to the other side. 4 over 3 x square plus 4 over 3 square x square, 20 over 3 x. Just use our calculator to find this value. Okay, we get plus 4 over 3 square, 37 over 9 x square is 20 over 3x. Just cancel out the x term, x variable, one of it, and we get x equivalent to 20 over 3 divided by 37 over 9, which is 20 over 3 divided by 37 over 9 is, we get 60 over 37, and this x, which we already found, is actually the length of this square. So since the area of the square is x square, and we get area of square is 60 over 37 square, which is oh my god, wait, 60 over 37 square, damn it, 3600 divided by 1369 centimeter, unit square. So that's our answer.